All right, so now we have seen how to define logistic regression, what the loss function is. So let us look at some different versions of the logistic regression. So recall that the logistic regression goes like this. So basically, we take a linear model, then apply our sigmoid function to that linear model, and we fit that model using a different loss function. So instead of using the mean squared error, we are using the minus log likelihood. Okay, so this S of z is a sigmoid function. So this is a particular sigmoid function which is called a logistic function. So this is a logistic function. But one thing that we could do is we could just use a different sigmoid function. So as long as the general shape is the same, as long as it looks like this, we can do it. So these are some alternatives. I know that probit regression, where the sigmoid shape function is the cumulative distribution function of the standard normal variable, that is sometimes used in practice. So inverse tangent and this z over square root of z squared plus 1, I just made them up, but hypothetically we could use them, right? So another thing that we could do is that if our true decision boundary is nonlinear, like here, then we may need powers of predictors. So this is something like a polynomial logistic regression, or often it is called multinomial logistic regression. Like in this case, the true decision boundary is something like a circle. It is in fact a circle, yeah, because I just designed this example, but it is kind of clear from here that it is something like a circle. So which means that the decision boundary is really x1 square plus x2 square equals 1, so minus 1 is 0. So since it has powers of the predictors, it means that we could use powers of predictors and insert them into the sigmoid function. So then we will train a logistic regression with powers of predictors rather than the original predictors. And then we can come up with all sorts of nonlinear decision boundaries. Sometimes we need multi-class classification. So by the book logistic regression is only designed for for binary classification, right? So what if we have several classes, like 3? So we want to separate them by some kind of straight lines. The idea is that we just fit k different one versus rest logistic models, right? So in this case, we would fit 3 logistic models. So the first separates setosa from the rest. Right? So it could probably be something like this. So the second model could probably be separating Virginica from the rest. It probably could be something like this. So the third model would be something that separates versicolor from the rest. But this is a bit tricky because versicolor cannot really be separated by a straight line, right? So for versicolor, we probably would have to come up with a polynomial logistic regression. But hypothetically, if we wanted to separate it by a straight line, it could probably be something like this. I don't know. It would be a very poor classifier, but hypothetically. So for multi-class classification, we would have to construct k different one versus rest logistic models. So the introduction to statistical learning in our textbook, it mentions two more different methods that are kind of based on the same ideas. I'm not going to cover them in class. I'm not going to test them in midterm tests, but it's just for your information. You can read about them, and you can even use them in your own course project for some extra scores. So here is the quiz.